Hi guys, Daniel here. Hope you're doing well. Hope you're studying hard. I think by the time you're watching this, you would have done paper one at the very least. So I hope that went well. Do let me know how it went in the comments. And yeah, so today we've got paper three of the Edexcel GCSE Mathematics higher tier for June 2023, last year's paper. And yeah, haven't done the solutions to this one. There were definitely a few tricky questions. I think the last one with the probability was especially tricky. There was a Frustum one that was a bit of a tricky one and a couple of others as well. But yeah, you'll have the timestamps in the description so you can easily navigate the video, go to whatever question you'd like. And yeah, that's pretty much it from me. Let's get into it. Okay, so question one says simplify m to the power of 2 or to the power of 3. So from our index flows, we know that we multiply the powers together. So it's going to be m to the power of 6, isn't it? And the next one, we need to simplify x to the 5 times x to the 8. So this one, we add the indices together. So it's going to be x to the power of 13. And then the last one says we need to expand 4p bracket p squared plus 3p. This isn't too bad. So we're just going to multiply the 4p with the p squared. This is going to give us 4p cubed plus 4p times a 3p is going to give us 12p squared. So the answer is just 4p cubed plus 12p squared. And that's it. That's question one. Okay, so question two says Johnny wants to know how much coffee he will need for 800 people at a meeting. Each person who drinks coffee will drink 2 cups of coffee. 10.6 grams of coffee is needed for each cup of coffee. Johnny assumes 68% of the people will drink coffee. Using this assumption, work out the amount of coffee Johnny needs. Give your answer correct to the nearest gram. Okay, so firstly, there are 800 people, but not all of them are going to drink coffee, right? Johnny assumes that's going to be 68%. So let's work out how many people he assumes will be drinking coffee. And to do that, we need to work out 68% of 800, don't we? Remember, this is a calculator paper. You can do this very, very quickly. Change this to a decimal by dividing by 100, 0.86 of its times, and then you just times by 800. So I'm going to work this out, put this into the calculator. So we'll do 0.68 times by 800. This gives me 544. So there's 544 people drinking coffee. Now, we know that each person who drinks coffee will drink 2 cups of coffee. So I'm going to say that one person from that sentence is going to equal 2 cups of coffee. So I'm just going to write 2 cups. Now, to get how many cups we need to just multiply by 544, don't we? Because we need 544 people. So we'll times this by 544 here, and times this one by 544 here. And this will give me 1088 cups. Okay, now we know how many cups are needed. And then this sentence tells us that there are 10.6 grams of coffee for each cup. So we can say that, well, from there, 10.6 grams, 10.6, sorry, 10.6 G is equal to 1 cup of coffee. So 1 cup here. And we have 1088 cups. So all we need to do is just multiply by 1088, don't we? So times by 1088 times this one by 1088 as well. And that will tell us how many grams is needed for coffee. So I'm going to just do this here. So it's going to be 10.6 times by 1088. That gives me SD 11,532.8 grams of coffee, but we need the answer correct to the nearest gram. So that's to the nearest whole number. That's going to be 11,533, isn't it? So I'm going to write 11,533 grams. And I'll just write to the nearest gram here in brackets. So this is our answer for part 8, 11,533 grams. 11,533 grams. Let me just double check that. Yeah, brilliant. Okay, now part B says Johnny's assumption is wrong. 72% of people will drink coffee. How does this affect your answer to part A? Well, our answer to part A was how many grams was needed for 68 people, right? Now, if there's a higher proportion, i.e., 72 people, if there's a high proportion of people that need coffee, then the way it will affect our answer is that we're going to need more grams, right? Or he's going to need more cups of coffee. So all you need to say is just something along the lines of Johnny will need more cups of coffee. And that's it. This question two finished. Okay, so question 3 says ACF and ADG are straight lines, BCD and EFG are parallel lines, and we need to show that the triangle ACD is isosceles given a reason for each stage of our working. Okay, so triangle ACD is this one here, and when you have an isosceles triangle, it just means that two of the sides are the same, meaning that the two angles are the same. So you're going to have two angles out of three which are going to be the same if it's isosceles. So we just need to work out all of the angles in the triangle, and we should expect to get two of them to be the same. So firstly, what I notice is that I've got this angle here, EF. Now, this is a parallel lines question. So I've got this angle here, and from our co-interior rule, these two have to sum to make 180. So this angle here is just going to be 180, take away 125, and that is just equal to 55, isn't it? It's going to be 55 degrees here. So I can say, remember, we need to give a reason. So I'm just going to say reason number one, or answer number one is going to be angle BCF is equal to 55 degrees since it is co-interior with the angle EFC. Perfect. And now, as well as that, we can work out this angle, right? This angle is going to be 55 as well because it's vertically opposite to that angle BCF. So I'm just going to write this as a vertically opposite. All right, V for vertically opposite. I'm just going to put number 2 here. And I'm going to say that the angle ACD is equal to angle uh, this one here, BCF, which is equal to 55 degrees. They're both 55 since they are vertically opposite. Since they are vertically opposite. Okay, now we have that one. As well as that, we can actually work out what this angle is too, because this is an angle on a straight line. Angles on a straight line at 180, so it's going to be 70 degrees, isn't it? So I can just say that one's 70 degrees. And I can say what this triangle's, that angle's called ADC. So I can say 3 angle ADC is equal to 70 degrees. Then you could just say angles on a straight line, on a straight line at 180 degrees. And then now we've got 2 out of 3 angles. To work out this one, remember angles in a triangle add up to 180. So I'm just going to add these two together and then take it from 180. So I'm going to do 70 plus 55. This is equal to 5. This is equal to 12, so 125, right? If that angle is 125, that means that this angle here at the top, which is the angle CAD, right? It's going to be, right here, angle CAD is just going to equal 180 minus 125, which is equal to 55, isn't it? So I can put this as 55. So I can just say for the last one is that this is angle CAD. For angle CAD, the angle at the top, is equal to 55 since angles in a triangle add to 180. And what do we have here? We've got a triangle with two sides that are the same, right? So we could say, to finish off, we could say angles in what was the angle? Angle ACD and angle. So ACD is this one, and angle CAD are both. Oh, I should say in the triangle. That's the first one I should say. In the triangle ACD are both 55 degrees. Therefore, 3 dots mean therefore the triangle. All right, triangle for this. Triangle ACD is isosceles. And that's it. You've given all of the rules, each stage of the working, that will give you the 5 marks. Let me just zoom out so you can see all of the working. And that's it. Brilliant. Okay, so question 4 says it takes 14 hours for 5 identical pumps to fill a water tank. How many hours would it take 4 of these pumps to fill another water tank of the same size for 2 marks? Okay, now with this type of question, it comes up a lot. This is just a classic case of inverse proportion, and you're going to see why. So I'm going to write out what they've told us. We've got 5 identical pumps. I'm just going to write 5 pumps. 5 pumps. And this is equal to 14 hours, right? It takes 14 hours for this water tank to fill. Now, whenever you see something like this, when you have a certain amount is equal to a certain amount of time or so on and so forth, you should always work out 1 unit, right? So in other words, I want to work out what 1 pump would be in terms of the time. Now, before we do this, think about it logically, right? If 5 pumps takes 14 hours, then logically, right, if we use our common sense, it should take 1 pump longer than 14 hours. So a common misconception would be for students to just divide both sides by 5, right? But that would be incorrect. And that is where the inverse proportion comes in. You do the opposite, right? Because it's going to take longer. So instead of dividing by 5, you're going to multiply by 5 instead. So I'm going to times each of these by 5. And then now 14 times 5 is going to be 70, isn't it? It's going to be 70 hours, right? So we know that 1 pump is 70 hours. Technically, you're not 5 times by 5 isn't 1, but you get what I'm doing with this inverse proportion. So we've got 1 pump is 70 hours, and now it says how many hours would it take 4 of these pumps to fill another water tank. So what we need to do now is split the 70 hours 4 ways. So I'm going to say that 4 pumps now. To get 4 pumps, we're going to have to divide this quantity by 4, isn't it? And 70 divided by 4, you can check on your calculator. This is just 17.5. So the answer is just 17.5 hours. And that's it. It's 2 marks. Okay, so question 5 says A and B are numbers such that A is equal to 2 to the 2 times 3 to the 4 times 7, and B is equal to 3 squared times 7 squared. And we need to find the highest common factor of A and B. It's only 1 mark. Now, what you want to do is you just want to create a Venn diagram, right? So I'm going to create a Venn diagram. I'm going to draw a circle like this here. I'm going to draw another circle like that over there. And then let me just make it a bit proportionate. So put it like this and put it in the middle. Yeah, so it's fine. And I'm going to call this A, and I'm going to call this B. Now, we just need to put these into the Venn diagram. Now, what do they have in common? Well, I can see they have 3s in common. How many 3s do they have in common? Well, B has 2 3s, 3 squared, and A has 4 3s, right? So they both have at least 2 in common. So I'm going to put a 3 squared in the middle here. That. And what else do they have in common? What I'll do actually, just so it's clear. So 2 times 2, I'm going to write these all out just so it's super clear. 3 times 3 times 3 times 3 times by 7. And then this is equal to 3 times by 3 times by 7 times by 7. So we can see quite clearly now that we've got 2 3s here and then 2 3s here, which is 3 squared, which is why it goes there. So that's a lot better now. Now, what else do they have in common? Well, I can see that they have a common factor of 7. So it's going to be here. And it's going to be here, isn't it? So we've got 1 common factor of 7. And that is it, isn't it? That is it. So I'm just double checking. Anything else? No, that's it. That's it. So in that case, the highest common factor is always the product of the numbers in the middle, right? So it's just going to be, all right, HCF is just going to be 3 squared times by 7, which is 9 times 7, which is just 63. Oops. So it's going to be 9 times 7, which is 63. So the highest common factor of these two numbers is 63. Now we need to find the lowest common multiple of A and B. So again, we need to use our Venn diagram, but we actually need to fill in the rest now. So what is missing? What haven't we used? Well, for A, I haven't used the 2 and these 3. So I haven't used these 2. I've got 2 2s I haven't used and 2 3s I haven't used. So it's going to be 2 squared here for these 2 and then 3 squared here for those 2, right? And then for B, the only one that's missing is that 7 here, isn't it? So it's going to go here. And then now, once you've done your entire Venn diagram, the lowest common multiple is just the product of everything inside. So I'm going to say that the LCM is going to equal 2 squared times by the 3 squared times by the 3 squared times by the 7 times by the 7. So now I'm just going to put this in my calculator and see what it gives me. It's going to be 2 squared times by 3 squared times by another 3 squared times by a 7 and another 7. This gives me 15,876. So the lowest common multiple is 15,876. And that's it. That's question 5 finished. Okay, so question 6 says lava flows from a volcano at a constant rate of 11.9 meters cubed per second. How many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? Give your answer to correct to the nearest day. Okay, so this is a 3 marker, and what they've told us is the amount of the amount of lava that's flowing every second, isn't it? So I'm gonna say that from the question, we know that 11.9 meters cubed of lava is flowing out every second. So I'm going to say this is equal to 1 second, right? Now we need to know how many days this amount of lava is flowing out from. So what I'd want to do is work out this rate in terms of days, isn't it? So what I would do firstly is convert this into to minutes, right? And I'll do this by timesing by 60, wouldn't I? So I'm going to times that by 60, and that will give me 1 minute, right? So that I'm just going to times this by 60 as well. So I'm going to do 11.9 times 60. 11.9 times by 60. This is equal to 714. So 714 meters cubed of lava flowing every minute. And now I'm going to try and convert this into hours, right? Because there are 60 minutes in an hour. So I'm going to times this by 60. That'll give me 1 hour. So I'm going to times this by 60 as well. So I'll do this here. It's going to be 714 times by 60. This is equal to 42,840. So 42,840 meters cubed of lava is thrown out every hour. And now this is easy. We can just turn this into days now. 1 day, we know that there are 24 hours in a day. So I'm just going to times this by 24 to give me the amount of lava flowing out per day. So I'm going to times this by 24. This gives me 42840 times by 24. This is equal to that number there, which is 1,028,160. So 1,028,160 meters cubed. This is how many meters cubed are flowing out every day. And let's look at the question again. It says how many days does it take for that number 67,205,600 meters cubed of lava to flow from the volcano? So what we need to do then is it's pretty simple now. Let's write this here. This is the amount of lava that we're dealing with, right? This here. And this is the rate per day. This is how much is flowing out per day. So we need to work out how many days this is. And that is just the same as asking, well, how many of these go into that, right? That will give us the number of days. So all we need to do is just divide, don't we? We need to do the bottom number, 67 million, blah, 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 divided by this number. This will give us how many days. So I'm going to do this here. I'll do it here. It's going to be 67, 205, 600 divided by that there, 160. So I'll put this into my calculator and see what it gives me. So I'll put this here. It's going to be 67, 205, 600. And we're going to divide this by 1028160. And this gives me SD 65.36364 blah 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 days. However, the question asked us to give it correct to the nearest day, which is to the nearest whole number, and that's just clearly 65, isn't it? So the answer is just 65 days. And that's it. This question 6 finished. Okay, so question 7 says, here is a graph of y equals x squared minus 2x minus 2, and we need to write down the coordinates of the turning point on the graph, right? Okay, so remember the turning point is just the minimum point in this case, right? Or the maximum if the graph was the other way around. So it's just the vertex as well. So what I'm just going to go zoom in, and the minimum point or the turning point is just going to be this coordinate right here, isn't it? Right here. And that is where x is equal to 1 and y is equal to -3. So therefore the coordinate is just going to be 1 minus 3. 1 minus 3. That's it. And then part B says, write down an estimate for one of the roots of x squared minus 2x minus 2 is equal to 0. Now, whenever you see roots and you've got an equation equal to 0, right, that means that you're just figuring out where the graph intersects the x-axis, because essentially y is equal to 0 here, right? So another way of saying this is just going to be the x-intercepts. X-intercepts, right? And as well as that, remember, if your graph is y is equal to, and it's now equal to 0, again, you can just deduce that y must be equal to 0, right? Which again is where the x-intercepts are. So all we're going to do is it says estimate, write down an estimate for one of the roots. So we only need one. So we're just going to figure out where the graph intersects the intercepts here. You know what, I'll do both and I'll just put one in the answer. So I'll just do this in green. There's a value right there, right? And there's also a value over here, isn't it? Now, for me, these are going up in 0.2. It's in minus 0.2, minus up before 0.6, 0.8. Yeah, so this looks to be in the middle of 0.8 and 0.6. I'm going to say this is 0.7 here, minus 0.7, right? And then this one is 2.2, 2.4, 2.6, 2.8. It's going to say this is 2.7 here, right? So these are the two roots, and I'm just going to just pick the positive one. So I'm just going to say x is equal to 2.7. So I can just say x is equal to 2.7. And that's it. Okay, so question 8 says a solid cuboid is made of metal. The metal has a density of 9 grams per centimeter cubed, and the volume of the cuboid is 72 centimeters cubed. And we need to work out the mass of the cuboid. So this is just compound measures, right? And this is there's a formula that you should know that connects the density and mass and volume together, and that is just the density is equal to the mass divided by the volume. What you can do is you can use a formula triangle to help you remember it as well. So put this here, D, and then M, and then V. And then in our case, they're asking us for the mass, isn't it? So if I was to rearrange this one, we can see quite clearly that it's just going to be, all right, D for density and V for volume is equal to the mass, right? And as well as that, looking at this formula triangle, if I cover the M, then it's just D times V, isn't it? So the mass is equal to the density times the volume. So what we can say is that the mass then, in our case, is going to be equal to the density, which they told us is 9, right? 9 grams per centimeter cubed, and the volume is 72, right? So I'm going to do 9 times 72, and I'll put this into my calculator, and this will be 9 times 72. This is going to be 648. So the answer is just 648 grams. And that's it. That's question 8 finished. Okay, so question 9 says some people were asked if they wanted a new television. 70% of the people said yes. 80% of the people who said yes wanted a television with a large screen. What percentage of the people asked said they wanted a television with a large screen? Okay, so there's a couple of things going on here. So firstly, there are 70% of people who said yes to a television, right? So I'm just going to say 70% is equal to yes, right, for a television, right? This is for any television. Now it says 80% of the people who said yes. So in other words, 80% of the people who said yes, which are these right here, right? And there was 70%. So you can actually just think of this as 80% of the 70%, right? So I'm just gonna write this here, who said yes, right? And I'm gonna write 70%. So you can actually think of this sentence here as just saying 80%, right, of the 70%, right? Because if you think about it, 80% of the people who said yes, well, there were 70% of people that said yes. So it's just a percentage out of another percentage, right? So it's just 80% of the 70%, in other words, right? And this is the people who wanted a large television screen. So what we're going to do is say, well, fine, I've got 80% of 70%. Write this as a decimal, right? 0.8 is going to be 80%. And then whenever we have of, this is just a multiplication, and this is just 0.7. So the answer is just 0.8 times 0.7, right? Put this in my calculator. 0.8 times 0.7 is 0.56, isn't it, to be fair? Yeah, 0.56. So 0.56, and the question asked us for the percentage, so we need to times by 100. So I'm going to times this by 100, and this will give us 56%. So it's just 56%, and that will give you the 2 marks. And that's it. Okay, so question 10 says ABD is a triangle, C is a point on BD, so C is over here, and we've got 2 triangles together, angles here, blah, 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 we've got distances, and it says we need to work out the length of D to C, which is this one here. We need to give answer correct to 1 decimal place. Now, firstly, when I look at this question, I have 2 shapes, 2 triangles joined together, and whenever I see these types of questions, I make a note of this. Whenever you see 2 shapes joined together, the key is the side that connects them both, right? And in this case, it's going to be A to C, right? It's always the same thing. So just make a note of this, guys. Whenever you see 2 shapes together, the side that connects them both is always the key to the question. So for me, before I even do anything, I know I need to work out that side. Now, having a look at what I've got here, I've got two right angled triangles, and I've got angles, right? So straight away, I'm thinking of trigonometry. Now remember, we need to work out what this side d to c is. So I'm going to call this x for now, right? This is the side we're looking for. Now, how can I work this out? Well, if I had one of the sides of this triangle, right, i.e. the one in yellow, then I could just use SOHCAHTOA with the x, right? But I don't. But I can do so with this triangle here because I've actually got a side and an angle. So we can use SOHCAHTOA here. So what I'm going to do is I'm going to label this triangle first. Now remember, this is the angle here. The side opposite the angle is always called the opposite side. So I'm just going to actually, not I'm going to do actually. I'm going to draw this triangle out again, just so it's clear. Like that there. And then this is a 41-degree angle. This is 6.8. This is A. This is C. And then this is D. This is B. Right? This side is called the opposite. And then the side opposite the right angle is always called the hypotenuse. And this leaves the adjacent side, but you could always remind yourself or remember it as the side in between the right angle and the acute angle that you have. So we've labeled a right angle triangle. How does SOHCAHTOA work? We now have to list the acronym. So I'm going to list the acronym SO, Ca, and TOA. And now I'll ask myself two questions. I'm looking for a side. Which side have they given me? I can see that they've given me, let me do it in green actually. They've given me the hypotenuse, right, which is 6.8. So I'm going to highlight this H here, and I'm going to highlight this H here. This tells me that straight away it can't be TOA. And then now, which side are we looking for? And it's the yellow side, isn't it, which is the opposite. It's the opposite here. So it's going to be SO. So we're using SO. This time I'm going to take this. So therefore, let's write out the actual formula. It's going to be the sine of the angle is equal to the opposite divided by the hypotenuse, isn't it? Now we're just going to plug in everything that we know. The angle in this case is 41 degrees. And the side is what we're looking for. I'm just going to call it O double P for now. And the hypotenuse is 6.8. So if I get my calculator and punch this in, or not yet actually, because remember, we need to rearrange to be fair. So we're looking for the opposite, which is this side here. I'm going to have to times both sides by 6.8, don't I? So if I times both sides by 6.8, it will be 6.8 times by sine 41. And this will equal the opposite side, isn't it? And then this is what I'm going to put into my calculator. So I've got my calculator here. So it's going to be 6.8 times by sine 41. And this gives me 4.461 blah blah blah. So what I'm going to do is I'm just going to write 4.461 blah blah blah. Now this isn't my final answer, so I never round, right? I always round at the very end. So why is this helpful? Because now I know that side in the middle. So I'm just going to rub this out here, and I'm just going to put this side. This is equal to 4.461 blah blah blah. Let me just double check that was the correct number. Yes, it was. So now, remember, we're looking for this side d to c, which is x. So I'm going to draw this triangle out now. I'm going to draw this one here. It's going to be like this. Like that, pretty much. And this is a 55-degree angle. This is point D. This is C. This is A. And I now know that this distance here is 4.461, blah, blah, blah. Now, this is a right angle. Again, I'm just going to do the same thing. So I'm going to use SOHCAHTOA. So first I need to label the triangle. The side opposite the angle is always called the opposite. So I'm going to put this as opposite here. The side opposite the right angle is called the hypotenuse. And the side in between the right angle and the acute angle is always the adjacent. So I'm going to call this the adjacent here. So I've got this here. Now we're looking for the adjacent because that's what x is. So again, go out your acronym SO, CA, and TOA. Now, firstly, ask yourself which side have they given you? Which side do you have? You've got the 4.461, which corresponds to the opposite. So I'm gonna highlight that O. I'm gonna highlight this O, and that tells me straight away we can't use CA. We're not using CA. And then the second thing is what side are they asking us to find? And that is x, which is the adjacent, and that is A. So it has to be TOA. So I'm going to circle this one. I'm going to use TOA. Now we write out the acronym, and that is tan of the angle is equal to the opposite divided by the adjacent. The angle in this case is 55. The opposite is that number that we found, 4.461, blah, blah, blah. And we're going to divide this by x, the adjacent, which is what we're looking for. So we are here. We need to get x on its own. And what you can do, whenever you see an x on the bottom here, right, I'll put it in green, you can just swap it with this one. Swap it with this one. So therefore, it just becomes x is equal to 4.461 dot 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 divided by tan 55, right? And algebraically, it's just the same as multiplying both sides by the x and then divided by tan 55. This is just a quick way to do it. But yeah, now we just need to plug this in. Now remember, I already have that number stored, the 4.46 blah blah blah. So I don't need to write it out again. I'm just going to do answer divided by tan 55. And this gives me 3.123. And what was the degree of accuracy? It was one decimal place. So it's just going to be, let me just double check again. It's going to be 3.1, isn't it? 3.1. It's going to be 3.1. And what is this in centimeters? Yes, centimeters. 3.1 centimeters. And that is to 1 dp. So we'll put this here. And that's it. And that's question 10 finished. Okay, so question 11 says the table shows information about the heights of a group of adults. The least height is 169, the greatest height is 186, median is 177, lower quarter out is 174, and the upper quarter is 180. On the grid, we need to draw a box plot for the information in the table. Okay, so this isn't too bad. Remember, box plots are just gonna look something like this, isn't it? This here, like this, pretty much. Where this is your lowest value, this is your lower quartile, your median goes here, upper quartile goes there, and then this is your greatest value. So we just need to plot this, the information given to us. Now, firstly, check the units of measurements or the values on the grids, right, just to see what the scaling is. So, firstly, for example, this is 165, this is 170, this is going to be 167.5, isn't it? And that tells me that each of these boxes are worth 0.5. So this will be 168, this will be this will be 168.5, and this will be 169, isn't it? So 169 is actually two boxes before 170. So just gotta be careful. So I'm gonna plot this now. So 169, I'm just gonna draw a line like this. It's gonna be two boxes before 170. It's gonna be around here. It's gonna be like that. And what I'll do, because it's quite difficult to draw with without a ruler on this software, I might just do it freehanded and try my best to straighten it up as possible. So that's going to be the least height. And now we need to draw a horizontal line going to the lower quartile, isn't it? Which is going to be 174, which is going to be 2 before 175, which is going to be over here, right there. And that's going to be the lower quartile. Now I need to draw a box over this now, which is going to be something like this. Just something like that, and then I need to finish off this box. So what would the next value be? The next value is going to be the median, which is 177. So it's going to be 176. It's going to be 1 before this, isn't it? So I know where to put it. 177 is going to be over here, essentially. And I'll just straighten this up so you can see. So like this here. Oops, I don't want to do that. I just want to 17. So have I lost my bearings? No, I haven't. 177 is going to be here, isn't it? Yeah, perfect. And now I need the upper quartile, which is 180, which is very easy to see. It's just over here. That, and then I'm just going to straighten this up. So it's like this, that, and then straighten up the bottom here, like this. So now I'm just going to draw a box to connect these lines. It's going to be like this, and it's going to be like that. And then I'm going to do it like this here. At the bottom, to connect at the bottom, it's going to be like this. Like that. Okay, that's great. And then now we need the greatest value, which is just 186, isn't it? So where's 186? That's going to be 2 after 185 because it goes up in twos. So it's going to be right here. And then I'm just going to connect this. Whoops. I'm going to connect this here. That. And then like that, isn't it? And then I'm going to just draw a vertical line to create a whisker. It's just going to be like that, and then straighten this up a bit. Like that. And then nearly done. Okay. Okay. So yeah, that looks great to me. Obviously, it's the best I could do with what I've got. But yeah, as long as you just make sure you've got the measurements, let me just make sure I've done this correctly. So that's definitely going to be 169 for sure. This one is the lower quarter, which is 174, which is right here, 174, which is slightly off, but it's fine. And then the median is 177. This is 175. This is 177.5. Yeah, this is 177. Perfect. And then this one is 180. That's fine. And then the greatest is 186, which is going to be yeah, right here. Brilliant. Perfect. So that's fine. That's done. That's part A. And then part B says the box plot below shows information, shows the distribution of the heights of a group of teenagers. And we need to compare the distribution of height of the adults with the distribution of the height of the teenagers. Now, this is 2 marks, and you're going to get 2 marks for doing two things. You're going to get 1 mark for comparing the medians, right? Making a comment about the medians. So I'm going to do this. I'm going to do this here. So comment number one, when we look at the medians, right, we can see that the adults' medians is much higher than the teenagers, right? So what are we dealing with here? We're dealing with heights, right? So we could just say the the median height for adults is much higher. So they're taller on average. So they are taller on average, right? You could just make a comment like that on average. So that's 1 mark, making a comment about the medians. You get the second mark for making a comment about the spread, right? Or about the range or the interquartile range. Either or, doesn't matter. So what we can see here is that, for example, we can work out the range, for example. The range for this one is going to be the greatest height minus the lowest height, which is going to be 186. 186 take away 169. So this is 17, yeah? So you could say range for adults, right? Which is equal to 17. I'll put it in bracket here, in brackets. And then we can work out the range for this one, which is going to be, what's the greatest height here? This is 177.5. This is going to be 178, isn't it? Right? 178, 179. Yeah, it's 178. So the greatest value here is 178. And the smallest value is 157.5, isn't it? So I'm going to do the range between those. So we can just say that it's going to be 178 take away 157.5, isn't it? And this gives us 20.5, right? So we could say this smaller smaller than the range for the teenagers. The teenagers. Which was equal to 20.5, wasn't it? Let me just double check that. Yeah, 20.5, right? So in other words, the teenagers' heights are more spread out, isn't it? Or you could say the opposite. The adults' heights are less spread. So you could just make a comment like that. So you could say adults' heights are less spread. And that'll be it. That'll give you the 2 marks. And that's question 11 finished. Okay, so question 12 says, show that x minus 1 times x plus 3 times x minus 5 can be written in the form ax cubed plus bx squared plus cx plus d, where a, b, c, and d are integers. So again, this one is just expanding, right? You've got brackets and they tell you it can be written in this form where you've got powers of x. You have to expand to do that. So what I'm going to do is I'm going to expand the first 2 brackets first. So I'm going to have x minus 1 and x plus 3. I'm going to expand these first. And when I do this, this is going to give me x and an x makes an x squared. And then an x times a 3 will make a 3x. And then I've got minus 1 times x, which is a minus x. Then I've got minus 1 times by 3, which is minus 3. I'm going to just tally this up a bit. So we're going to have x squared plus 3x take away an x is 2x, isn't it? So it's going to be x squared plus 2x take 3. And then I'm going to replace these 2 brackets with this expression here. So the question just becomes x squared, so let me just put this back here, becomes x squared plus 2x minus 3, and then multiply by x minus 5. And then now all you're going to do is you're going to multiply this x squared with that. So it's just going to be x squared times x is going to be x cubed. And it's going to be x squared times a minus 5, which is minus 5x squared. And you're just going to repeat, it's going to be 2x times an x, which is a plus 2x squared. And then we're going to have 2x times a minus 5, which is going to be a minus 10x. And then we're going to have a minus 3 times an x, which is a minus 3x here. And then we've got minus 3 times a minus 5, which is going to be a positive 15, isn't it? So we've got this here. Now we just need to tidy up. So what do we have? We've only got one x cubed term, so that's fine. I've got minus 5x squared plus a 2x squared. Minus 5 plus 2 is negative 3, isn't it? So it's going to be negative 3x squared. And then for the x's, we've got minus 10 minus a 3, that's minus 13. So minus 13x, and then we've got plus 15. And that's it. It's fully expanded. So you could just say that your integers are a is equal to, this is going to be a 1. B is going to equal minus 3. C is going to equal minus 13. And D is going to be 15. And that's it. You don't actually need to put this here, but it's just always good to be clear. But yeah, that's it. And that will give you the 3 marks for question 12. Okay, so question 13 says an expression for the nth term of the sequence of a triangular numbers is n multiplied by n plus 1 over 2. Prove that the sum of any two consecutive triangular numbers is a square number. So there's a couple of things going on here. It's algebraic proof, and they've given us expression for the nth term. So I'm going to write this out again. So nth term, right? I'm just going to write nth here. It's going to be n bracket n plus 1, right? Divided by 2. That's the first thing. Now, we need the sum of two consecutive triangular numbers. So in other words, we're going to need the one after n, isn't it? Which we can call n plus 1, right? Now, you've got to be very careful here. Because what I'm going to do, I'm just going to use actual numbers so you guys can see the pattern, right? So for example, let's say I had the fourth term, right? Then in our case, well, then that would mean, well, I'm going to replace n with 4, isn't it? So it'd be 4, and then it will be 4 plus 1, right? All over 2, right? That'll be the fourth term. And then the one after it will be the fifth, right? And this is going to be 5, and then it's going to be 5 plus 1, right? All over 2, and so on and so forth. Now, just imagine you didn't know what 4 plus 1 was equal to. Let's just say we know it's 5, but imagine we didn't know it was actually equal to 5. Then what you could do is you could just say, I'll just do it here. We could say that 4 plus 1, right, is equal to 5, right? So what you could do is say, well, fine, if I want the one after, I'm going to replace this here, I'm going to replace this here. Then technically speaking, if I call this 4 plus 1, for example, then this is going to be a 4 plus 1 here, and this is going to be a 4 plus 1 here. And I'm going to highlight this. Let me just make it a bit better so it's clear to see. So it's going to be, just so it's super clear to see, it's going to be a 4 plus 1 here. And then in the bracket, it's going to be 4 plus 1 and then plus 1 all over 2, right? Now, remember, whatever goes here will go here, isn't it? Right? And here. This is where the ends are. Can you see? Here, here. Whatever goes there will go there. And then if it's 4 plus 1, then this 4 plus 1 is going to go here. And this 4 plus 1 is going to go here. So we need an expression for the n plus 1th term. So based on that, we could say that the n plus 1 term is going to be, well, remember, I'm going to highlight it in yellow again. If this is n plus 1, then the one on the outside has to be n plus 1 as well. So it's going to be n plus 1 here. And then multiplied by another n plus 1 here. And then plus the 1. And this is all over 2. So this is an expression for the n plus 1th term, right? Which is the term after n. So we've got two expressions. Now we can just tidy this up a little bit. So it's going to be n plus 1. And then it's going to be 1 plus 1 is 2. It's going to be n plus 2 all over 2, right? This is the n plus 1th term. So we've got this here. Now, we need to show that the sum of any two consecutive triangular numbers is always a square number. So there's a couple of things going on here. What I'm going to do is I'm just going to move this to the side because we don't need this anymore. I'm just going to move this all the way here just so it's out of the way. Okay. Now, if we have a square number, right, then what that means, algebraically speaking, then we have some expression that can be written as a perfect square. So essentially, when we're trying to prove that two consecutive numbers is a square number, it means that we have to add them together and we should be able to factorize our expression to give us a perfect square, essentially. So we need to add these together and then factorize. So I'm going to do this here. And what I'm going to do, because I don't really have that much room, do I? I'm going to minimize this here, just so I've got enough room to work with. So I'm going to put this here right in the corner. and I'm going to work with the two expressions. So I'm going to work with this expression. This is the nth term. I'm going to work with this expression here, which is the n plus 1 term, which is simplified. So we need to add these together. So it's going to be n and then n plus 1 all over 2. Just do it here. Plus n plus 1, n plus 2 all over 2. Now what I would do first is I would expand both numerators. So it's going to be n squared plus n all over 2 plus, and then this one is going to be n, and then we'll make an n squared. And I've got n times 2, which is a plus 2n. I've got 1 times n, which is an n. And I've got 1 times 2, which is a 2. Got this, and this is all over 2. So now I can simplify this a bit further to give me n squared plus n over 2 plus, and then this will simplify to be n squared plus 3n plus 2 all over 2. Now, they have the same denominator. We can combine the fractions now. So I'm going to write one long fraction bar. So let me just make it a bit neater. Like this. And this is going to be n squared plus n squared plus 3n plus 2 all over 2. Now, I can simplify this a bit more. So it's going to be, I've got 2n squareds, don't I? And I've got an n and a 3n, right? This is going to make a 4n in total, and then plus the 2, and this is all over 2. Now I've got this here. Well, you should notice that every single term has a factor of 2 in it. So what you can do is, I think it's best to do it this way. Take our factor of 2 to give n squared plus 2n plus 1, right? That's what it would be if you take out the 2. It's going to be all divided by 2. Now we can see quickly we've got a common factor of 2 and 2. We can cancel like this. And that just leaves us with this expression here, n squared plus 2n plus 1. So what I'm going to do, just so I don't run out of room, I'm going to move this all to the left here. So I can make a bit of room. Can move a bit more to the left. Okay, so that's fine. So that means that our expression is n squared plus 2n plus 1. Now remember what the question asked. It says that we need to prove that the sum of any two consecutive triangle numbers is a square number, which we know means that we have to get some sort of square. And we've simplified it to get this expression here. So what we need to do is ask ourselves, well, can this be factorized? Can this be put in the brackets? Yes, it can. It's just a quadratic, isn't it? So I'll just do it up here. Now, the number at the end is a 1. What two numbers multiply to give 1 and also add to give 2? It's just the factors 1 and 1, isn't it? So I'll just put here, the factors of 1 and 1 will times to give 1, and they will add to give 2. So therefore, we can put this into two brackets like this. We're going to have an n here, we're going to have an n here. And then we've got the two factors, which are just both plus 1s. So what do we have here? We've got two brackets, right? And they're the exact same thing, meaning that we can just write this as n plus 1 all squared. And that's exactly what they wanted, a square number. We've been able to show that these two triangular numbers, we add them together and it simplifies all the way down to something squared. So therefore we've proved it. And in GCSE, they're not that strict, but in A-level maths, you should always write a little conclusion. So what you could say is that you've got this here, and you could say, therefore, the sum of any two consecutive triangular numbers is a square number. Just a little statement. They're not too strict in GCSE, but it's always a good habit, especially if you want to do A-level maths as well. But yeah, that's it. So you put this here, n plus 1 all squared, and then just write a little statement. And yeah, that's it. Okay, so question 14 says, OAB is a triangle, OBC is a sector of a circle center O, and we need to calculate the area of OBC. Now, this is how many marks? This is a 4 marker. Now, firstly, when I look at this question, it reminds me of question 10. Remember, we've got two shapes and they're joined together. And we know from what we saw before is the key to these questions is always the side that connects them both, which is definitely this side. So I know that this side is going to be key here. Now, again, let's look at the question asking us to calculate the area of OBC. And we know that OBC, right, is a sector. They've told us it's a sector. So they actually asked us to calculate they're asking us to calculate the area of a sector. And what you should remember is your formula for the area of a sector. And that is just theta, or the angle, divided by 360 multiplied by pi r squared, the area of a circle. Right? So that's something you should commit to memory. It's not in the formula book or sheet, I don't think. But yeah, theta over 360 times by pi r squared. So I'm going to put this here. Area is going to equal the angle over 360 times by pi r squared. Now, when I look at the information given to us, well, this angle is given, right? It's 80 degrees. So I can just replace this with an 80. So it'll be 80 over 360 times by pi r squared. So we need to figure out what the radius is. So I'm just going to zoom in a bit now. So the radius, remember, if this is the sector, right? And they've told us that the center's O, then this distance here in yellow is going to be the radius, isn't it? And so is this one, to be fair. Yeah, so these are both the radii. Now, how do we find that distance? Because that's the key to the question. Well, they've given us a triangle on the left, right? And it hasn't been put there for no reason. It has a purpose. So when I look at the triangle on the left, I need to calculate that side in yellow. Well, what can I use? Well, I can see a triangle. I've got angles. I've got sides. It's definitely trigonometry, right? And what comes to mind? Well, it could probably be the sine rule, the cosine rule. It can't be SOHCAHTOA because it's not a right angle triangle, so it's going to be one of those two. And another important skill is identifying which rule to use. And with this one, we've actually been given two sides and an angle in between, so it's going to be the cosine rule. Remember, the formula for the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a. And you can use this to find a side if you have two sides, 1 and 2, and the angle in between. You could use it to find the opposite side to the angle. So we're going to go and use the cosine rule. So what I'm going to do is I'm just going to write the formula here again. A squared is equal to b squared plus c squared minus 2bc cosine a. And yeah, with this one, what you want to do is once you've done the cosine rule a couple of times, all you need to remember is that the b's and the c's are just going to be the sides, either side of the angle in between. So I'm going to say that a squared is going to equal, or r squared because I'm looking for r, same thing, is going to be equal to 9 squared plus the 6 squared minus those two sides again, 9 and 6, and then the cosine of the angle in between, which is 35 in this case. So all I'm going to do now is just put this into my calculator, see what it gives me. So putting this in is just going to be 9 squared plus 6 squared minus 2 lots of 9 and 6. It's going to be cosine of 35, which is equal to 28.531 blah blah blah. 28.531 blah blah blah. And then to get a, I need to square root. It's going to be a square root of that. And this is going to equal square root of that is going to be 5.341, right? A is going to equal 5.341, right? So this is our answer. Now remember, A is just the radius, isn't it, right? So we found out the side in yellow, which is the radius. So we could say, I'm just going to say that the radius is equal to A. Yeah. So the radius is just equal to 5.341 blah blah blah. Now, remember, we're trying to find the area of the sector OBC. We said that the formula is this here. We already had the angle 80 degrees way at the beginning. We needed the radius and we found that now, so we could just punch this into here. So it's going to be 80 over 360 multiplied by pi, and then the radius is 5.341 blah 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 all squared. So now I'm just going to put this into my calculator, see what it gives me. So but it says it's going to be a fraction 80 over 360. I'm going to multiply this by pi, and then it's going to be that number, which I already have stored in my calculator. I don't need to write it out again, squared. And this gives me 19.9187. So I'll write 19.9187. And it says it wants three significant figures. So it's just going to be 19.9. And it's going to be centimeters squared, isn't it? So it's just 19.9. And I'll give you the 4 marks. Okay, so question 15 says we need to factorize a squared minus b squared for 1 mark. Now straight away, you should recognize that this is just the difference of two squares. And this is just going to be equal to a minus b multiplied by a plus b. Okay, so that's done. And part B says we need to show that 2 to the power of 40 minus 1 is the product of two consecutive numbers. Now this is part B. In part B, we were asked to factorize a squared minus b squared. And I've got a subtraction there, so you can kind of read them into the lines. Definitely going to be something to do with what we did in part A. So what I would do is I'm going to write this out again. I've got 2 to the 40, take away 1. And what I want to do is I want to try and write these as the difference of two squares, the same way we did it in part A. So what I'm going to do is I'm going to put subtraction here. I'm going to put square here, like that. I'm going to do square here, like this. Now this one is easy. 1 to the power of anything we know is always 1. So I could write a 1 here. 1 squared is 1, that's fine. Now 2 to the 40, I've got a squared here. So I need something to make sure that when I expand this power, I get 40 here. Now you can just remember your index law. If I have a to the power of b, all to the power of c, then we just multiply the powers together. So essentially, I need a power whereby when I'm multiplying by 2, I get 14. That's just 20, isn't it? So I can write this as 2 to the 20 all squared. So we've got this. Now, based on what we can see in part A, this is a difference of 2 squares because we have something squared and we're taking something else away. So we can just say, imagine that this 2 to the 20 is your A. It's going to be 2 to the 20, take 1, and it's going to be 2 to the 20 plus 1, right? Same thing we did in part A. Whereas in this case, A is equal to 2 to the power of 20 and B is equal to 1. I'll write it here so it's clear. A is equal to 2 to the power of 20 and B is equal to 1. And we're just applying the same formula. Now, remember, we're trying to prove that this is the product of 2 consecutive odd numbers. So we need to analyze what we have in the brackets here. Now, firstly, I've got 2 to the power of 20 in both. And then I've got a subtraction of 1 and then an addition of 1, right? So there's a difference going on here. So what I'm going to do is I'm going to analyze 2 to the power of 20. And this is just multiplying 2 by itself 20 times, isn't it? Right? Now, 2 is an even number. If I keep multiplying by 2, it's going to be even. So I'm multiplying 2 by itself 20 times. And this is definitely an even number. There's no two ways about it. So what we have here is we've got an even number, take away 1, and we've got an even number plus 1. So I can actually write this. I could say, from this, we could say that we've got 2 to the 20, which is even. We've got an even minus 1. And we've got an even plus 1. Right? Now think of a number line, right? An even number, take away 1 is going to give you an odd number. So we've got an odd number here. And times by an even number plus 1 is going to give you another odd number. So these are both odd. We just need to show that they're consecutive. So what we can do, just to finish off, let me just move this to the side here. Well, if you've got 2 to the 20, got a number line like this, like that, right? Now remember, 2 to the 20 is an integer, right? If we keep multiplying 2 by itself 20 times, it's just going to be a really big whole number. So if I've got 2 to the 20 take 1, then this is going to be an integer as well. And this one is going to be an integer as well because we're just adding 1. And you can see that, again, this is even, this is odd, right? So we can see that we have 2 consecutive odd numbers, isn't it? There's one odd number after the other. So they're 2 consecutive odd numbers. So you can just say, just to finish off, that both 2 to the 20, and I'll just write plus or minus 1 just to indicate we're doing both, are odd consecutive odd numbers, doesn't matter, are odd consecutive, or you know what I'll do? I'll just write are two consecutive. I'll just write the same way they've written it. So I write are 2 consecutive odd numbers. And that's it. Finished. Okay, so question 16 says, on the grid, enlarge the triangle T by a scale factor of -2 with center of enlargement -2, 2. Okay, so firstly what I'm going to do is I'm going to plot this of enlargement, which is over here, -2, 2. And now I've got 3 points, right? So I'm just going to do this in different colors as well. So I'm going to put this one here, and I'm going to put this in red. I'll do it in orange to be fair. This one is in orange. I'll do this one in yellow. Right? Okay, so I've got to enlarge this now. Firstly, we've got a scale factor of -2. Now, let's just ignore the minus for a moment, right? If I wanted to enlarge this by a scale factor of +2, right, then all that would happen is, well, I'm at my center of enlargement. And how do I get to this point in blue? Well, I have to go 4 units to the left, don't I? -2 to -6 is -4. And if I enlarge it by a scale factor of 2, then I would have to go twice as far away. So I'd have to go -8 units, or 8 units to the left, isn't it, right? So that's what would happen if it was a +2. However, the negative just told you to go in the opposite direction. So I would have to go, in this case, 8 units to the right, and so on and so forth. And then another way I like to think of it as vectors, right? So I'll just show you what I mean. I'm going to list this as number 1, 2, and 3, like this. Now, for example, the first vector, to go from the center of enlargement to the first point, I'm going 4 units to the left. And as a column vector, that's just -4, 0, isn't it? I just go 4 units to the left, I don't go up or down. So what you want to do is you're going to multiply this vector here by the scale factor, which is a -2. right? And when I do this, well, minus 4 times a minus 2 is just going to be a positive 8. And then obviously 0 times minus 2 is 0. So that tells me I just got 8 units to the right, which we knew already because the negative just tells you to go in opposite direction. But it's just quite clear to see with the vectors here. So to get this one, or to get this point number 1, I need to go 8 units to the right. So I'm at minus 2. I need to go 8 units to the right. So I'm going to do minus 2 plus 8, which will take me to a 6, isn't it? So this is going to be this point here. It's going to be this point here. And I'm going to call this number 1. No, you're just going to keep going. So I'm going to call this number 2. And then I'm going to ask myself, well, what is the vector that takes me from the center of enlargement to this point here? I have to go 1, 2, 3 units to the left, right? So that's going to be a minus 3 here. And then once I'm here, I have to go 3 units down. So that's another minus 3. So this is the vector to go from the center of enlargement to that point 2. But remember, we're going to multiply by that scale factor, which is minus 2. And that's going to be minus 3 times minus 2 is a positive 6. So this must be positive 6 as well. So that tells us we need to go 6 units to the right and then 6 units up to get to this point in yellow. So I'm here. I need to go 6 units to the right. I'm at minus 2 on the x-axis. Minus 2 plus 6 will take me to 4 right here. So I'm 6 units to the right now. And now I need to go 6 units up. I'm at minus 2 on the y coordinate, aren't I? So I need to go 6 units up, take me to positive 4. So this is going to be the new point. I'm going to put this in yellow here. So the new coordinate is here, so be 4, 4. And then the last one, so I'm going to call number 3, right? How do I go? So we need to go 5 units, isn't it? Because it's just going to be 2 more. 5 units to the left to go from this red point to here. So it's going to be minus 5. And then once we're here, we need to just go 3 down again, like that. So therefore, the vector is minus 5, minus 3. And then I'm going to multiply this by minus 2. And that will give me minus 5 times minus 2 is a positive 10. Minus 3 times a positive 2 is a positive 6. So I have to go 10 units to the right and then 6 up. So I'm here. I need to go 10 units to the right. So I'm at minus 2 on the x-axis. If I go 10 units, it's going to be minus 2 plus 10, which will take me to a positive 8. And then once I'm here, I need to go 6 units up. So again, I'm at minus 2 on the y-coordinate, so I'm going to be over here. So I'm just going to put this in red now. I'm going to be over here, aren't I? And now the coordinates, we might as well just plot them here. The coordinates, this coordinate is going to be 6 minus 2. This one is going to be 8, 4. And this one is going to be 4, 4. And all you're going to do now is just draw a triangle in between. So I'll do this here. So I'm just going to do it like this. Like that. Hopefully that gives me a nice triangle. Yeah, brilliant, perfect. And yeah, that's it. That'll give you the 2 marks. Okay, so question 17 says, here is a distance time graph, and we need to find an estimate of the gradient of the graph at time t at time 2.5 seconds. You must show how you get your answer. Okay, so we're dealing with a graph which is curved, right? This is a curve, and ask us for the gradient at a specific point. Now, the way you find the gradient of a point when you're dealing with a curve is you have to draw a tangent line. Super, super important. So make sure you remember this. You just got to draw a tangent line at that point, and the gradient of that tangent line will be the gradient at the point. So what we're going to do is it says at 2.5, right? So I'm going to plot that there. So 2.5 is going to be right here, isn't it? This point right here, right there. And what I always do when I'm doing this question, I always choose the point that they've given us. So 2.5 is going to be the t coordinate or the x coordinate, right? 2.5. And what is the y coordinate here, or the distance? That looks to be, I think that's bang in the middle of 20 and 22, right? Because it goes up in twos, isn't it? So I'm going to say this is 21, right? That's 1 point. Now I need to draw a tangent through this point. So I'm going to get a line and then draw a tangent through it. So hopefully it shouldn't be too bad. It's going to be something like that. Okay, that's a bit too steep. Let me do it like this to just draw a bit nicely. I don't have a ruler, so I'll have to bear with me. Okay, so that seems okay. That's not too bad. I think it could be a little bit better if I move it down a bit. And then let me just try again. Okay, that seems a lot better. Okay, yeah, that seems great. So now what I'm going to do is I'm just going to pick another point, and I'm going to pick a point that looks pretty great. And that looks to be this point right here. This was like a brilliant point. That point over there is that is 3, and this is 30. Perfect. So now all you're going to do is you're going to figure out the gradient. And remember, you're just going to do the change in y over the change in x, isn't it? Right? Obviously, we're dealing with t and d. So we're just going to do the y2 minus y1. So it's going to be 30 take away 21, the two y coordinates. 30 take away 21. And we're going to divide this by 3 minus 2.5. So it's going to be like this here. Whoops, I wrote a 2. Apologies. 3 minus 2.5. 3 minus 2.5. And 30 take away 21 is 9, right? And then 3 take away 2.5 is 0.5. So it's 9 divided by 0.5, which is the same as 9 times 2, which is 18. So an estimate for the gradient is just going to be 18. And it's going to be meters per second, isn't it? Right? 18 meters per second. That's going to be the time here. So we'll do 18 meters per second. That's going to be the estimate for the gradient. Now, that's part A. Part B says, what does the gradient of the graph represent? Now, what are we dealing with? We're dealing with a distance time graph. And you should know that the gradient of a distance time graph just represents the speed or velocity, right? So all you have to do here is just write, this just represents the speed slash velocity. Either one will give you the mark. And that's it. That's question 17 finished. Okay, so question 18 says, a solid frustum is made by removing a small cone from a large cone as shown in the diagram. The slant height of the small cone is 6 centimeters as shown. The slant height of the large cone is 10 centimeters. The radius of the base of the large cone is 3 centimeters. And we need to calculate the total surface area of the frustum. And we need to give us the three significant figures. And they've given us the formula here for the curved surface area, which is pi r. And this is a 5 marker. Okay, now what I would do is look at the last line. So the actual question, calculate the total surface area of the frustum. I would actually just figure out what that actually means. So I'm going to draw the frustum again, right? Just so I can refer to it. So I'm going to just draw frustum. I'm going to just draw a circle like this, like that. I'm going to draw a slightly bigger one, like that. And then I'm just going to connect these lines just to get the frustum. So like this, essentially, like this. And then I'll just join it up in a second. And then this one like this. And then let me just join these up so it's nice and neat. That's fine there. And then this is fine here. Okay, so this is my frustum, right? And they're asking us for the total surface area. Well, how many surfaces does this frustum have? I can count 3. I've got 2 circles. I've got one on the top here. So I'm going to put in yellow. This is one surface, like this. And I've got one on the bottom, which is slightly bigger. It's going to be this one here. I'm going to do this like this. This is another surface here. And then I've got the one around the frustum, isn't it? Which is going to be this in the middle here, isn't it? So the answer to the question is just the areas of each of these colors. Once I work these out, I just add them together and that's the answer. So it's important to have a structure so you know where you're going and what you're doing. We need to work out these areas here. Now, firstly, we know the one on the bottom, isn't it? Because the radius, as given in the diagram, right, is 3 centimeters, right? And this is a circle. So we can just use pi r squared, isn't it? So I'm going to say this area here is just going to be pi and then 3 squared. And this is equal to 9 pi, isn't it? So that's one area. 1 down, 2 to go. So I'm going to just put this here. I'm going to just put number 1. This is 9 pi, like this. Perfect. Now, we need the circle on the top and the curved surface area in the middle. Now, what you should always remember and recognize with cones, right, and especially when you remove a smaller one from a large one, is that they're actually mathematically similar. And I'll show you why. So, for example, imagine we haven't removed the cone. There's an angle here, right? Now, if I remove the cone, then surely this angle, which I'll call maybe theta, is going to be the exact same for the smaller cone and for the larger cone, right? And another thing as well is if I was to draw a line like this, right? Remember, this is a horizontal line, and this is a line here, right? Now, these two lines are horizontal. These are parallel lines. If I was to draw another angle like this here, I'm going to put X here, and another one like this here, X, right? Then this is going to be corresponding angles, meaning that this angle is the same. And this is going to be the exact same on this side as well. If this is an X as well, or another angle, doesn't matter really, but it's going to be the same, right? So all of these are going to be the same. So these are definitely mathematically similar. So you don't need to prove this or show this, but it's just something to be aware of. When you remove a smaller cone from a larger cone, the two cones are mathematically similar. So what I'm going to do now is I'm just going to rub this out and I'm going to just draw those two cones, right? So I'm going to draw a smaller cone like this. So it's going to be something like that. And then I'm going to draw 2 lines to connect them at the top, like this. And then I'm going to just tidy this up, like this here. I'm going to do another one like this, like that. Okay, this is my smaller cone, and what I'm going to do is I'm just going to copy this and then paste it and make a bigger one, right? And when I do this, it's definitely going to be mathematically similar because I'm just enlarging it, isn't it? Okay, perfect. Now this is my small and large cone. Now what do I know? I know for the small cone, I know that this distance here is 6 as given to us in the diagram, and as well as that, this one is the larger one's slight height is 10. So I can put a 10 here. Same side, isn't it? Same thing on either side, so I can put a 10 here like this. Now, because they're mathematically similar, it means that there has to be some scale factor whereby I multiply 6 by a certain number and it will take me to this 10. And that is just called the scale factor. And the way you work this out is you just do the larger value divided by the smaller value, isn't it? So it's going to be 10 divided by 6, which is equal to 5 divided by 3. So the scale factor is 5 over 3. What you can do is just put this in your calculator just to see what the number is. 5 divided by 3 is equal to 1.6 recurrent, but it's better to leave it as a fraction. So I'm going to just write it as a fraction. The scale factor is 5 over 3. So when I do 6 times 5 over 3, you can just verify 6 times 5 over 3 gets me to 10. Now, because we're dealing with scale factors, right, it means that this scale factor must be consistent across all of the different lengths of these two objects. Now, what do we know about the large object? The large object had a radius of 3. And now, since we know the scale factor, it will allow us to calculate the radius of the smaller object, isn't it? Because remember, if I'm going from 6 to a 10, I times by that 5 over 3. But now I want to go from a bigger object to a smaller object here. I need to divide by that scale factor of 5 over 3. So to work out this one, you're just going to do 3 divided by 5 over 3. So I'll just put this into my calculator. So we get 3 divided by the scale factor, which is 5 over 3. This gives us 9 over 5, which is 1.8. And this tells us that the radius of the smaller cone is just 1.8. So just put 1.8 here. Perfect. So now this is good news because we now know that this radius here is 1.8 because this is the base of the smaller one. So put 1.8 here. And that would mean that we can work out the area of that surface. So I'm just going to call this number 2. This here. So do number 2 here. And this is just going to be pi times 1.8 squared. And I'll put this into the calculator. And this will give me pi times 1.8 squared. This is equal to 81 over 25 pi. And I'm going to leave it in terms of pi just because it's easier to work with. 81 over 25 pi. So we've got two areas. Now we just need to work out the curved surface area. Now remember, we're dealing with a frustum whereby it's made by removing the small cone from the large cone. So if you think about it, if I want to work out the surface area of the frustum, right, then surely it would be the surface area of this entire large cone, right, all around. And then I would just remove the surface area of the smaller cone, right? So I need to work out these two and then take them away. And that will give us the area of the frustum, isn't it? So what I'm going to do is I'm going to work out the curved surface area of each of these and then take them away. So I'm going to call this, I'll call this number 1 and I'll call this number 2. And the curved surface area of the smaller cone, all right, CSA of number 1, right? This is just going to equal, remember, the formula is given to us as pi RL. So it's going to be pi, and then the radius is 1.8 for the smaller cone, and the length, the slight height is 6. So I'm going to put this in here. So let me just make that a bit neater. So I'm going to put 6 here, and then let's see what this gives us. I need to do pi times 1.8, so take that off, 8 times by $6. So I get this here, which is 54 over 5 pi. And then the curved surface area of the larger cone, all right, CSA. And then number 2, this is going to be pi times the radius, which is 3. And the slight height is 10, isn't it? So this is just 30 pi. I don't need to put this into my calculator to be fair. That's 30 pi. And that means, all right, therefore, the curved surface area of the frustum is just going to equal those two, take away each other. So it's going to be 30 pi, the larger one, take away the 54 over 5 pi, isn't it? Now punch this into the calculator. This will give us 30 pi, take away 54 over 5 pi. And this gives us 96 over 5 pi. So we now know the curved surface area of the frustum, the remaining surface area that we needed. So I'm just going to write this here, 96 over 5 pi. This is the one in the middle. So I'm just going to put number 3 here. We just double check. I haven't written any wrong numbers yet. 96 over 5 pi. So now we could say, therefore, the total surface area, all right, SA is just going to equal the areas of number 1, plus the area of number 2, plus the area of number 3. And this is just going to equal 9 pi plus the 81 over 25 pi, right? And then plus the area of the curved surface area in the middle, 96 over 5 pi. And then now you're just going to put this into your calculator and see what it gives you. So I'm going to do it here. It's going to be 9 pi plus 81 over 25 pi plus 96 over 5 pi. And this gives us 786 over 25 pi. But we don't need it in terms of pi, do we? We need it to a certain degree of accuracy. So I'll just check. It's 3 significant figures. So I'm going to just press SD. And this gives us 98.77. That's 98.8, isn't it? It'll be 98.8. And there'll be answer centimeter squared. So put this here. And that's it. And that'll give you the 5 marks. Okay, so question 19 says Sana needs to draw the graph of y equals 3 to the x for x between 0 and 4. She draws the graph shown on the grid. And we need to write down one thing that's wrong, that Sana has done wrong. Now, what you should recognize, we've got y to the 3, right here. We've got y is equal to 3 to the power of x, right? Now, what you should notice is that this here is an exponential graph, right? And what you should know is that the graph definitely has this curved shape like this. I'm just going to draw axes like this. It's definitely okay. Let me just move this down a bit. So it's not the issue. The general curve is not the issue, right? But what you should know is that any exponential graph of this form, right, which you can generalize to be y equals a to the x, right, is going to have a y-intercept of 0, right? Because remember, the y-intercept of any graph is when x is 0. So if I put y equals a to the 0 here, well, from our indexes, we know anything to the power of 0 is 1. So that would mean that 3 to the 0 is also equal to 1. So the graph should actually pass through 1. And the graph will look like this. Like that, essentially. So all you could say here as one thing that Sana has done wrong is the graph should go through 1. So I'll do it here. The graph should go through. You put the coordinate when x equals 0, y equals 1. And that's it. 1 mark. Okay, so question 20 says, prove algebraically that 0.123, where the 2 and 3 are recurring, can be written as 61 over 495. So this is just some standard algebra. So remember with this one, all you're going to do is you're going to let x equal this number here. So I'm going to say x is equal to, and I'm going to write this out in long form. So remember, there's the dots are on 2 and the 3, so that means that those are the values repeating. So it's going to be 0.1, and it's going to be 2, 3, 2, 3, 2, 3, 2, 3, and so on and so forth. Now, your job is to get multiples of this x here, tens, hundreds, thousands, and you need this decimal part to be the same. So what you can do is, firstly, if I multiply by 10, right, I could have 10x here. This is just going to give me 1 point, and then it's going to be 2, 3, 2, 3, 2, 3, 2, 3, and so on and so forth. Now, this is no good because the decimal parts aren't the same. So I'm going to multiply again. So it'll be 100. Now I'm going to multiply by 10 again. And this will give me 12 points. And it's going to be 3, 2, 3, 2, 3, 2, 3, 2, 3, and so on and so forth. Now, again, these are no good because they are alternating. We need it to be the same. So if I do it one more time, times by 10 again, it's going to be 1000x, right? And this is equal to, it's going to be 123, right? 0.23, 2, 3, 2, 3, 2, 3, 2, and so on and so forth. Now when I look at any of these, I can see that, well, this one starts as a 2, so 2, 3, 2, 3, 2, 3. So there's this one. So it's going to be these two that I can take away from each other, and that will eliminate this decimal part within it. So if I do this here, I'm just going to write, it's going to be 1000x. I'll just do it here. 1000x, and I'm going to take away the 10x. It's going to be like this here. 10x like this. And this is equal to, now this one is just going to be, I'll try it again, 123.2323 2, 3, and so on and so forth. And this one's going to be 10 was 1, isn't it? So it's going to be 1.232323, and so on and so forth. Now, if I take these away, so subtract, I've already done it here to be fair, I already put the column here. I'll do it here just so it's clear, right? If I take these away and I put a subtraction here and a subtraction here, right? Well, what will happen is that, 1000x take away 10x is going to be 990x, isn't it? It's going to be 990x. And then 123 take 1 is going to be 122. And now this part, the decimal parts, are just going to cancel, aren't they? Because they go on forever and they're the exact same. So I can just say goodbye, goodbye. And I'm left with 122.0. Now remember, we're trying to show that this can be written as that. And remember, x is this. So all I need to do now is just figure out what x is. So I'll just write it one more time. It's going to be 990x is equal to 122. And then now we've got x is going to be 122. I'll just go down a bit. 122 divided by 990. And now these are both even. Divide top and bottom by 2. 122 divided by 2 is going to be 61. 990 divided by 2 is just going to be 495, isn't it? And that's it. We've proved it. Because remember, x, we said at the very beginning, was equal to that. So therefore, if x is 0.123, blah, 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 it has to equal 61 over 495. And that's it. That's your 3 marks. Okay, so question 21 says, solve 1 over x plus 4 plus 3 minus 2 minus 2x is equal to 1. And this is 4 marks, I believe. Let me just check. Yes, 4 marks. So this is an algebraic fraction. The way you solve algebraic fractions is you solve them at normal fractions. What you want to do is you want to combine the fractions. And in our case, we've got two denominators which are algebraic, right? They're in terms of x. So what we need to do is find the expression for the LCM. And that's just going to be the product of them, of the two, isn't it? So it's going to be x plus 4. And then it's going to be a 2 minus 2x, isn't it? This here. The same way you would multiply two normal fractions with numbers that aren't common, right? So for example, 3 and a 5 you times to make 15 and so on and so forth. So this is going to be our LCM. Just write equals right, LCM here. Now, in this case, what you're going to do is you're going to say, fine, well, I've got this here. Our new denominators are going to have the x plus 4 and the 2 minus 2x, isn't it? So I'll just write this like this. This is equal to 1. It's going to be x plus 4 and then 2 minus 2x. And it's going to be another x plus 4 and then 2 minus 2x. Okay. So now we need to write the equivalent fraction. Remember, fractions are equivalent. So whatever I've done to the bottom, I must do to the top. So if I look here, I had x plus 4 at the start. I also have an x plus 4 here, but it's also being multiplied by 2 minus 2x now. And that means that I have to multiply the numerator by that same 2 minus 2x, isn't it, to keep the fractions equivalent. So I'm going to have to multiply both sides by 2 minus 2x, like this. And that would mean on the numerator, I'll just have 1 and then 2 minus 2x, like this. And then now, for the second one, we've got a 2 minus 2x here, which we have here as well. But we can see that there's now an x plus 4, meaning that we have to multiply by x plus 4 as well. We'll multiply this one, the numerator by x plus 4. And that would mean I have a 3 bracket x plus 4. Like this. Okay, so we're here. Now, since they have the same denominator, we can combine this to make one singular fraction, can't we? So I'm just going to put this here. And I'm going to say that we've got 1 and then 2 minus 2x plus 3 and then x plus 4 and then all over x plus 4 and then 2 minus 2x. This is equal to 1. Okay, so we're here. Now, this is one way to combine the fractions. Another way, which you're probably familiar with, or which your teachers probably taught you, is to cross multiply. And that is very quick and much more efficient than doing this. However, it's always important to do this so you guys understand why we're able to cross multiply. So I'll just show you very quickly. I'm going to write that question again here. So it's going to be, I'll just write like a green box here. There. There. And I'll just call this cross multiplying. Okay, so the question is 1 over x plus 4 plus 3 and then 2 minus 2x is equal to 1. Now, to cross multiply, what you're going to do is you're going to multiply this denominator with this numerator here going across. So it's going to be 1 and then bracket 2 minus 2x. And then plus, and it's going to be this denominator multiplied by this numerator going across, which is going to be 3 and then bracket x plus 4. And then you're just going to divide this by the product of these two. So it's just going to be x plus 4 and then 2 minus 2x. And this is equal to 1. Right? And as you can see, it's the exact same thing we got here. We did it very quickly. However, it's always important to understand why you're doing this. So yeah, you can just pick whichever way you prefer in the exam. But yeah, let's continue. So we are here now. Now, remember, we need to solve this. So we're finding x essentially. So what I'm going to do now is I'm going to expand the brackets. So let's put this here. So it's going to be, if I expand that 1, it's just going to be 2 take away 2x, isn't it? And this is going to be plus, and it's going to be 3x plus 12. And then it's going to be on the denominator. I need to expand this. X times a 2 is going to be 2x. X times a minus 2x will be minus 2x squared. 4 times 2 is 8. 4 times minus 2 is minus 8x. And this is equal to 1, isn't it? Now, I'm going to tidy up now. Let's collect the like terms and so on and so forth. So I've got, firstly, I'm going to put it in order of the x terms, right? The highest x term. So minus 2x plus the 3x will give me 1x within it. So it'll be x here. Then I've got 2 plus 12, which is 14, isn't it? So it'll be plus 14. Now, looking at the denominator, I can see that the highest x term is an x squared. So we're going to put minus 2x squared here first. And then I'm going to have a 2x minus an 8x, which will give me minus 6x. And then I have just a plus 8. And this is equal to 1. So we're here. Now, this comes up all the time. You've got an algebraic fraction. You're trying to figure out what x is. You're not going to be able to move things around when you have a fraction. So what you should always do, guys, when you get to this step is to multiply by the denominator. You don't want any fractions when you're dealing with algebraic expressions because you want to be able to move things over the equal sign and so on and so forth. You can't do that if you've got a fraction. So we're going to multiply both sides by this denominator here. And this will give me x plus 14 is equal to 1. And it's going to be minus 2x squared minus 6x plus 8. And now just expanding this 1, it's just going to be the exact same thing, isn't it? Minus 2x minus 6x plus 8 and x plus 14. Now, we are here. Remember, we're still trying to figure out what x is. Now, if I look at the terms here, I can see that the highest power of any x is a 2. This tells me that this is a quadratic equation. And the way we solve quadratic equations is you just make everything equal to 0 on one side. You're going to move everything from you're going to move everything from the right to the left to get the left side to be x squares and so on and so forth equal to 0. So that's what we're going to do here. So I'm going to move everything from right to left. So it's going to be x plus 14 is, and then if I add on the minus 2, it's going to be plus 2x squared, minus 6 is going to be a plus 6x, and then minus 8 is going to be 0. Like this. So we get this here. And now tidying this up, I'm going to put the x squared term first. 2x squared. I have an x plus a 6x. That will give me a 7x right here. And then I've got a 14 minus 8. And that is it's plus 6, isn't it? It's plus 6. Yeah, because 6 plus 8 is 14. So yeah, this is it. So we are here. Now we need to solve this. This is a quadratic. Now there's many ways to solve a quadratic. Remember, this is a calculator paper. You can use the quadratic formula. You can complete the square, although I wouldn't recommend, or you can attempt to factorize. What I will do is I'm going to attempt to factorize because it's always a good algebraic technique to have. So firstly, we've got a 2 in front of the x squared term. So we can't factorize this normally. We have to use the AC method, isn't it? Where we multiply the a term, the number in front of the x squared with the number on the end. So we're going to do 2 times 6. And this is equal to 12. And now we need 2 factors of 12 that will also add to make the number in the middle here, which is a positive 7. And that's just going to be a 4 and a 3, isn't it? 4 plus 3 is equal to 7. 4 times 3 is equal to 12. So this is definitely correct. So now we're going to just break this down. We're going to have 2x squared, and then we've got a 7x here, but we're going to break it down into the 2 numbers that add to make 7. So it's going to be a plus 4x here, and then a plus 3x here, and then add 6 is equal to 0. So now what we want to do is you're going to split your terms down the middle. You're going to factorize the first 2 terms and the last 2 terms. So if I factorize the first 2 terms, I'm going to have a 2x on the outside, and this will give me an x plus 2. And then if I take out a factor here, I can take out a 3. I'll get another x plus 2 here. This is equal to 0. And then now we need to solve. So what we can do is if you look closely, we've got this common factor of x plus 2 here. We're going to factorize this out of these 2 terms. It's going to be x plus 2, right? This is going to be on the outside of the bracket like this. And then what we are left with, right, is a 2x here and a plus 3. And that will go there. and this is equal to 0. Let me just tidy this up a bit so it's a bit neater. 2x plus 3. Okay. So we factorized. Now, whenever you get to this step and you need to factorize, all you do is you're just going to set each of your brackets equal to 0. So it's going to be x plus 2 is equal to 0. That will mean that x is equal to -2. That's one solution. And this one here, it's going to be 2x plus 3 is equal to 0. There's a bit more to do now. I'm going to take the 3 over. It's going to be 2x is equal to -3. And then we're going to divide by 2 to give us x is equal to -3 over 2. So therefore, your two answers is going to be x is equal to -2 or x will equal -3 over 2. And that's it. That will give you the 4 marks. Okay, so question 22 says, given that the vector A multiplied by 2, 6 plus B multiplied by 8, 2 is parallel to the vector 13, 6, find an expression for B in terms of A. Now, firstly, they've asked us to find the expression for B in terms of A. That means that our answer is going to be B is equal to something with A in it, right? That's the first thing. Now, secondly, they've said that this vector here, right, is parallel to this vector. Now, firstly, what you need to remember is the definition of parallel vectors. If vectors are parallel to each other, it means that they're just multiples of one another. So I'll just give you an example, right? Let's say we've got the vector 13, 6, right? Like this. Then what does this actually mean? It means that you're going across by 13, right? And then you're going up. You're going to the right by 13 and you're going up by 6. And the vector itself is going to be the hypotenuse here, right? This is going to be the vector itself. This is the direction you're going in. Now, if I wanted a parallel vector, well, it could just be twice as long. It just has to go in that same direction. It has to have this same angle, wouldn't it? Right? So for example, let's just say I multiply this by 2 to give me 26, 12, right? Then that would be going twice as long across 26, and it'd be going twice as high. 12, right? But the direction would still be the same because we're going to have two of those vectors here. This is going to be the vector 13, 6, and then we're going to have another 13, 6 here. So you can see that when vectors are multiples of one another, they go in the same direction, and so they're parallel, right? Now, we can extend this because this 26, 12, I can actually rewrite this as, I'm going to write 26, 12. I'm going to write this as 2 lots of 13, 6. The main thing is this vector 13, 6. And then you can just keep going. Well, another one would just be if we multiply it by 3. And we could just extend this to form a relationship. We could just say that there's just a multiplier called a k, right? And it'll be 13, 6. So what we can do with all of this is say that, well, if a vector is parallel to another, we can just express it as a multiple, some value of k multiplied by that vector. So firstly, what we can do now is, now that we've got this relationship, what I'm going to do is just work with this. We've got a multiplied by 2, 6, right? And b multiplied by 8, 2. What we can do is expand this. So I'm going to do this here. I'm going to have a, and we're going to have 2, 6 like this. This is just going to equal 2a and 6a. Like that. Let me just move this here. It's going to be a 2a and a 6a. Like that. And then the b, 8, 2, right? You just got to multiply that letter with every component. So it's going to be 8b and then 2b. Now, remember, this is a vector. Even if there are two of them, they're being summed together. We can actually add these, can't we? So what we can do is say then that this here is just going to become 2a, 6a, plus 8b, and then 2b. And this will equal, altogether, let's make this a bit neater, it's going to equal one big column vector, which is going to be 2a plus 8b on the top, and this is going to be 6a plus 2b on the bottom. And this is our vector, which is parallel to this vector 13, 6. And we know that if we have a vector which is parallel to 13, 6, it can just be written as a multiple where the value is k, right? So we can actually say then, based on that, we could say, I'll just do it here. It just means that this 2a plus 8b and then 6a plus 2b is just equal to this here, k and then 13, 6, like that. Because it's parallel to 36, so it has to be a multiple of 36. And then what we can do now, I'm running out of room, what we can do now is expand this case. So what I'm going to do actually, just because I'm running out of a bit of room, I'm going to move this, I'm going to make this smaller. I'm going to put this here, I'm going to move this here, and then I'll just put this here and then work underneath here. Okay, so what we can do is say, well, that k we can multiply, expand, so it's going to be 13k and then 6k, like that, and then we've got this here, 8b, and then 6a plus 2b, like this. So now we've got two vectors which are equal to each other. Now, remember, vectors are in components of x's and y's. The component on the top is your x's, and the component on the bottom is your y's, right? Going from left or right or up or down. Now, if these two vectors are the same, then surely the components must be equal, right? This one must be equal to that one, and this one here must be equal to that one. So what we can do is create two equations, can't we? So I'm going to just do this here. We're going to have 2a plus 8b is equal to 13k. And we've got 6a plus 2b is equal to 6k. Now we've got these two equations, equation 1 and equation 2. Now when I look at this, straight away I'm thinking a simultaneous equation, right? Now it is, but the issue I have is that there's a lot of variables, right? There's a and b, which is fine, but we've got k as well. We've got an extra variable k. That's an issue. Now remember, k, right, is some number, some non-zero number, some multiple, right? What you can do is a trick here, right, to eliminate k. Now, what I'm going to do here is I've got the equation 1, I've got equation 2. I'm going to just do equation 1 divided by equation 2. And what will happen is that I'm going to have the 2a plus the 8b, right? I'm going to divide this by equation 2, 6a plus 2b. And this is going to equal the 13k, and we're going to divide this by the 6k. And then what will happen here is that these k's are going to cancel, aren't they? So you're just going to be left with 13 over 6. This is good because now we've eliminated that third variable k. So what I'm going to do, I'm just going to do it here. I've got room here. Yeah, I'm going to do it here. So doing this, it's going to be now, it's just going to be 2a plus 8b is equal to 13. And then divided by 6a plus 2b divided by 6, isn't it? So now, again, just like with the other question, we have an algebraic fraction because we've got letters of a and b. You want to get rid of the fractions. So what we can do is cross multiply, can't we? So we're going to do the 6 times by this numerator here. It's going to be 6 bracket 2a plus 8b. And this one's going to be this one here. It's going to be 13, and then it's going to be 6a plus 2b. That. And now remember, the question asks us, I forgot the bracket here. Remember, the question asks us to find the expression for b in terms of a. So we just need to get b on its own. So let's multiply these together and see what we get. So 6 times 2 is 12, it could be 12a here. 6 times 8 is 48, I believe, 48b. This is equal to 13 times 6 is 78, I believe, 78 a. Let me just double check that. 13 times 6. Yeah, 78a, good stuff. And 13 times 2 is 26. So it's going to be 26b here. Okay. So now we are here. Now we just to get b on its own. So I'm going to move the b's to the left and a's to the right. So it's going to be 48b, take away that 26b, is equal to 78a. 78a, take away the 12a. And then now tidying this up, 48 take away 26 is 22. So it's going to be 22b here. And then 78a take away 12a is going to be 66a. So now to get b on its own, it's going to be b is equal to 66a divided by 22. 66 divided by 22 is just 3. So therefore b is equal to 3a. And that's it. Just put this here. b is equal to 3a. It's quite a lot for 3 marks, but yeah, not much we can do to be fair. But hopefully this all makes sense. Okay, so question 23 says, a circle-wise equation x squared plus y squared is equal to 25. The point P with coordinates minus 3, 4 lies on the circle. Alex says that the tangent to the circle at P crosses the x-axis at the point minus 8, 0. Is Alex correct? You must show how you get your answer. And this is 4 marks. Now, firstly, whenever you see this type of question, this is what we call the equation of a circle question, or what I call it anyway. What you want to do is visualize this. You want to draw a picture of what's going on. So firstly, what I'm going to do is I'm going to get an x and y axes. So it's going to be pretty much like this, essentially. Right? Okay. Now I'm going to label this x and y, obviously. Label this y. Label this x. Okay. Now, Firstly, we're dealing with an equation of a circle. What you should remember is your general formula for the equation of a circle, and that is x squared plus y squared is equal to r squared, and that is where your center is at the origin 0, 0. Don't worry, in GCSE they don't ask you questions where your center is not at 0, 0, so you don't need to worry about that. But yeah, the general formula is x squared plus y squared is equal to r squared, right? Where r represents your radius. Now in this case, we can see that the x squared y squared, right? The number on the end is 25, right? So in that case, we can say that these two are the exact same, meaning that we can say that r squared is equal to 25, and then to get r, we just square root, don't we? So that means that the radius of this circle here is 5. So what I'm going to do is I'm going to draw a circle. I'm going to have, it's going to be a sketch, and I'm going to say that the radius is 5. So I'm just going to get a circle going, which is going to be something like that. Maybe that looks fine to me. Put this in the center. So it's like this, like that. A bit lower. Yeah, that looks fine. That looks brilliant. So now what we can say is that the radius is 5. I'm going to just put, so this is going to be x squared plus y squared is equal to 25. We know the radius is 5, so I'm just going to put a 5 here. I'm going to put a minus 5 here on the other side, and I'm going to put a minus 5 here, and it's going to be 5 here. So we can see quite clearly the radius is 5. Now, it says that the point P with coordinate minus 3, 4 lies on this circle, right? And it says, Alex says that the tangent to the circle at P crosses the x-axis at the point minus 8, 0. So firstly, let's put that point. Now, let's plot that point, I should say. So if minus 5 is here, let's just say minus 3 is maybe here, for example. And then let's say 5 is there. Let's just say 4 is about there. Let's just say 4 is here, right? So we're going to say the point P is there, and this is the point P, which is I'll do it here. This point P is minus 3, 4, like this. Okay, now there's a tangent to the circle at P. Now, another thing you need to remember, a tangent is just a line that just touches your circle at a specific point. It just skims the circle. So if I was to draw a tangent passing through this point P, it's going to look something like this, isn't it? Do like a rough sketch. It's going to look something like that, essentially. Like that. This is our tangent line. And Alex says that the tangent to the circle at P crosses the x-axis at minus 8, 0. So what Alex is suggesting is that this point here, where the tangent crosses the x-axis, this is a minus 8. This is Alex's claim. And we need to figure out whether or not he's correct or not. Now, with this question here, as I said before, comes up a lot. There's a couple of things you need to know. You need to remember the general formula for the equation of a circle. You also need to remember your circle theorems, right? There's a circle theorem that states that the tangent to a circle and the radius meet at a 90-degree angle. That's one of the things you need to remember. And as well as that, what is the other thing? Yeah, that's pretty much it actually. So yeah, you need to remember those. Oh yeah, of course, just remembered. The last thing you need to remember is perpendicular lines, right? When two lines are perpendicular, the gradients are the negative reciprocal of one another. So again, let's just run through that. You need to remember the general formula for the equation of a circle, x squared plus y squared is equal to r squared. You need to remember the circle theorem, that the radius and the tangent meet at 90 degrees. And you need to remember, what was the last thing I said? Yeah, perpendicular lines, that the gradients are the negative reciprocal of one another. So just make a note of those 1, 2, and 3 things, and you'll be fine with this question. So let's go ahead and do that. So what I'm going to do actually, because I need to draw a radius here, I'm going to put P, I'm just going to say this is P, and put it on this side, minus 3, and then 4. And then what I'm going to do is I'm going to draw a radius from the point P to the center, right, which will be like this. I'm going to do it like this here. So like this here, and then I'm going to put this here. Like that. And then according to our circle theorem, right, these meet at a right angle, like this. In other words, the gradient of this line in green is the negative reciprocal of the gradient of that line. So what we need to do is work out the gradient. And what you can always do with this question is the same type of topic, same type of question, you work out the gradient of the radius. How can we do that? Well, we've got one point on the radius, which is P, minus 3, 4. But as well as that, we've also got this point because it passes through the origin, 0, 0. Right? So I'm going to call this O. So, and I'm going to call this the radius here, right? I'm just going to call this R. So we can say from here, I'll just do it here. The gradient of the radius, or R, remember, we're just going to do y2 minus y1, isn't it? I'm going to do m is equal to, I'm going to use y2 minus y1 over x2 minus x1. And then the two coordinates I'm going to use are the point P. So the y coordinate of P is a 4. So it's going to be 4 take away. The y coordinate of O is just 0. divided by x coordinate of p is minus 3. I'm going to take 0 away. So we can say that the gradient is just 4 over minus 3, isn't it? Which is the same as minus 3 over 4, right? Sorry, no, it's not. I just meant to put the minus on the outside. It's the same as minus 4 over 3. Yeah, this is the gradient of the radius. So I'm going to say here that the gradient of this line M is equal to minus 4/3, right? This is the gradient of the red line. Now, according to our rule for perpendicular lines, the green line has a gradient which is a negative reciprocal. Now, remember, how do you find the negative reciprocal? You just flip it and then just multiply by minus 1. So in our case, if it's minus 4 over 3, the perpendicular gradient is going to be positive, right? The negative will turn to a positive, and then flip over the fraction 3/4. So we now know the equation. So we now know the gradient of this green line. Now, what we need to do, because remember his claim is that the line passes through the point minus 8, right, on the x-axis. So what we should do is work out the equation of this line, right, and figure out where the x-intercept is, right? So we need to find the equation of a line, and that means we need to remember the general formula for an equation of a line, which is y equals mx plus c, and I'll do it here actually, to be fair. I'm going to say this line here has a general formula of y equals mx plus c, right? However, we now know the gradient of this is 3/4. So we can update this equation and say that the equation is now y equals 3/4 x plus c, isn't it? Now, we need to figure out what c is. How do we get c? Well, remember, when you're doing the equations of lines, if you have the gradient and you're looking for c and you know a point that passes through, you just substitute those points in. And we do. If you look at the picture, we can see that the point P, which is minus 3, 4, passes through the line, the tangent that we're looking for, right? So I'm gonna put a bracket. This is the tangent line. Yeah. So what I'm gonna do is I'm gonna put this here, and I'm gonna say that I've got y equals 3/4 x plus c. And I know that the point P minus 3, 4 passes through, right? So what we could say then is that, well, if it passes through, then we can replace x and y with minus 3 and 4. So it's going to be y is 4, so it's going to be 4 is equal to 3/4, and then x is minus 3 plus c. Now tidying this up, this is just going to give us minus 9 over 4 plus c, and then now we need to add this over, so it's going to be 4 plus 9 over 4, which is equal to c. Now you can put this into your calculator, but I'll just do it in my head. 4 is the same as 16 over 4, right? Plus 9 over 4, which is equal to c. Same denominator, 60 plus 9 is 25. So therefore, we can say that c is 25 over 4, and this is our y-intercept. So now we have a complete equation for the equation of this tangent here, right? So we can say that to finish off, or we can say the equation of the tangent, right, is just going to be equal to y is equal to the m, which was 3/4 x, plus c, which is 25 over 4. So we now have the equation of the tangent. Now remember the claim. Alex says that the tangent to the circle crosses the x-axis at the point minus 8, 0, which you've labeled here. So we just need to make sure that's true. And remember another thing. When you pass the x-axis, if you cross the x-axis, right, this is when your y-coordinate is equal to 0, isn't it, right? Because if you're along the x-axis, you haven't gone up or down. So the y-coordinate is always going to be 0 there. So we can use this to figure out what our value of x is, right? So we could say now that crosses the y-axis, crosses the x-axis, I should say, crosses the x-axis at y is equal to 0. And that would mean that we're just going to replace this with 0 here. So it's going to be 0 is equal to 3 over 4x plus 25 over 4. Now, to solve this, I don't like the fractions. What we can do is multiply everything by 4 to get rid of the fractions. If I do 0 times 4, that will still leave me with 0. 3/4 times 4 will give me a 3, so it'll be 3x here. And then 25 over 4 times by 4 is just going to be 25, isn't it? This here. So we get this here. We get 0 is equal to 3x plus 25. I'm going to move the 25 over, so we get minus 25 is equal to 3x. And then now we're just going to divide by 3. Minus 25 divided by 3 is equal to x. And this value is where the graph crosses the x-axis. And last time I checked, this is not minus 8. But you could always just double check this to be safe. So I'm going to put this into the calculator here. Minus 25 over 3 is equal to minus 8.3 recurring, isn't it? Right? So I could just say this here. minus 8.3 recurring, right? So that actually means that this value here that I labeled as 8 is actually not 8. It's actually minus 8.3 recurring. So Alex is incorrect. And what you can say here just to finish off is you could just say Alex is incorrect, as the tangent passes through that coordinate here, minus 8.3 recurring, right? And the y coordinate is 0, right? Remember, this is minus 8.3 recurring, the y coordinate is 0. And you could say it passes through this coordinate, not minus 80. And that's it. That will give you the 4 marks. Okay, so question 24 says, there is a total of y counters in the box. There are x pink counters and 5 blue counters in the box. The rest of the counters are green. The ratio of x to y is equal to 1 to 3. Freda takes at random 2 counters from the box. Find in terms of x an expression for the probability that Freda takes 2 counters of the same color. Give your answer as a fraction in the form ax squared plus bx plus c divided by dx squared plus ex, where a, b, c, d, and e are integers. Okay, so there's a lot going on here. It's the last question of the exam. It looks very, very tricky, but we just need to break it down into bits and bobs right now. Firstly, I'm going to say that the total they've told us is equal to y. So we know the total is y, and there are different colors. There are pink, blue, and there are green colors. So I'm going to say, we know that there are x pink colors. So I'm just going to say x is equal to pink. And they've told us that there are 5 for blue. And we don't know how many green colors there are. So I'm just going to say that G is just going to equal green, right? There are G amount of green colors. So we can create an equation with the total amount of colors. We can say, well, the total, which is equal to y, right? It's just going to be equal to these added together. X plus 5 plus G. That is one equation here. Now, they've also told us about the ratio of x to y, and it's equal to 1 to 3. Now, this comes up a lot whereby they give you some sort of ratio and you're dealing with algebra here. Now, whenever that's the case, what you should remember is that you can express a ratio as a fraction, right? So I'm just going to do it here. X to y is equal to 1 to 3, right? You can just divide the first by the second, and you're going to get x divided by y is equal to 1 over 3. And these mean the exact same thing. This is just in a fractional form. And what you can actually do is just cross multiply to figure out maybe y in terms of x and so on and so forth. So if I cross multiply, I'm going to get a 3x here, and this is going to be y, isn't it? So we now actually know that y is equal to 3x, right? And another way you could have done it is if you look at this ratio, is x to y is 1 to 3. So for every 1 of x, there are 3 of y, which means that y is just 3 times x. So you could have done it that way as well, but this is also another way. So I'm going to put this here. Okay, so let me just get this. Okay, going to move this here. So we know that 3x is equal to y. And what I'm going to do is, this is actually quite helpful because I now know that I now know that I now know y in terms of x, right? So I could say that I've got 3x is equal to x plus 5 plus g. And this is quite helpful because now I can figure out g in terms of x just by rearranging, right? So I could say, well, that would mean that I'll have 3x, take away an x, take away a 5 will equal g. And that would mean that g is just equal to 3x take x is a 2x, and then we've got minus 5. So now we know that the greens are just 2x minus 5 in terms of x. So I can rub out this and put a 2x minus 5 here. Perfect. And as well as that, we also figured out that the total is also equal to 3x as well. Yeah? Okay, brilliant. So now the question says, Freda takes at random 2 cards from the box, and we need to find in terms of x expression for the probability that Freda takes 2 cards of the same color. Now, firstly, what you can do is try and visualize this with a probability tree, but there's quite a lot going on here. You don't actually need to do that, although you can, but it can take a lot of time. But if we try and just work with the probability that they're asking us for, and that's taking 2 counters, you'd be able to spot the pattern and see how you actually work it out. So firstly, if I want to take the same color, right, and we're taking 2 counters, right? So I'm going to say same color. Well, then how many ways can that happen? Well, one way is if I take 2 pinks. So I'm just going to write P and P. I'm going to write PP. Or I could take two blues, all right, B, B here. Or I could take the probability of two greens. These are the ways that I can take two counters and they're the same color. Either they're both pink, both blue, or both green. So it's our job now just to work out what these probabilities are. Now let's go ahead and do this. Let's start with two pinks, for example. So again, let's list out everything that we need for the pink, right? Right, for pink here. We know that the total is equal to 3x. We've worked that out, right? And there are X amount of pinks. So I'm going to say pink is equal to X, right? So if I want the probability, right, of two pinks, well, I'm just going to write P and then P here. Well, the first pink, well, it's just going to be the amount of pinks that I have, which is X. And I'm going to divide this by the total amount of counters in the bag, which is 3X, isn't it? Now, remember, this is one of them, right? To get the other one, remember, it's a pink and a pink. What I can do actually is I could actually put an and here so it's super clear, right? So I'm going to write P and I'm going to write and P, P and P. Now, remember, and when you're dealing with probability trees means that you multiply. So I'm going to have to multiply this here. And then remember, I've already taken a pink already. So I'm going to write second here. In my second go, I'm going to have one less pink to choose from. So it's going to be X take away one, right? And I'm going to divide this by, now remember, if I've taken one pink, there's going to be one less in total as well. So it's going to be 3x take one, isn't it? And that would be an expression for taking two pinks. And what you can do is just tidy this up a bit. I'm just going to put the brackets together. X minus 1 over, and then 3x, and then 3x minus 1 like this. And this here is an expression for taking two pinks. And now we need to do the same for the blues and the greens, right? So go do the blues now. And what do we know? The total is still 3x, right? But how many blues are there? There are 5 blues, isn't it? They told us. So I'm going to write blue is equal to 5, right? So now we can say the probability of a blue and a blue, all right, B and B. This is going to equal, well, on our first go, how many blues are there to start with? Remember, they told us that there are 5 blue counters. So it's going to be 5 out of the total, which we know is 3x. And then now, remember, we need to multiply. And then if I've taken a blue counter already, I'm going to have one less to choose from. So it's going to be 4. And I'm going to divide by one less counter in total, which is going to be 3x minus 1. And in this here, we can simplify times these together. 5 times 4 is 20. It's going to be 20 over, and then 3x, and then 3x take 1. Perfect. Now, we need to do the greens now. So we do the greens now. Green, this here. The total is 3x. And we figured out an expression for the green in terms of x. It was 2x minus 5, isn't it? So I'm going to write green here is equal to 2x minus 5. So I'm going to set the probability of getting a G and a G, two greens. This is going to equal, sure about that. Just there. Okay. It's going to equal, firstly, how many greens do we have to start with? It's going to be 2x minus 5. And we're going to divide this by the total, which is a 3x. Huh? And now we're taking our second pick. We've already taken a green, so we have to take one away. Now be very, very careful, right? 2x minus 5, when you take one away from that, it's going to be 2x take 6, isn't it? I see a lot of students thinking it's a 4. It's going to be minus 6, isn't it? And then divided by one less in total, it's going to be 3x minus 1. And then I can just tally this up. It's going to be 2x minus 5, 2x minus 6 over 3x, and then 3x minus 1. Now, these are all expressions for taking either two pinks, two blues, and two greens, right? I remember what the question asks us for. Freda wants to take two colors and they need to be the same color. So we need these, which is what we've got now. So all we need to do is just put this into the formula or into the equation, right? So how much room do I have? I don't have that much room, to be fair. What I'll do is I'll do it on the side there. I'll finish here on the side there. So I'll just continue here. Now, if I want the same color, right, we can see that same color here. It's just going to be equal to these. So remember, we've got these here. I'm going to call this option 1, option 2, option 3, just so it's super clear. This is option 1, this is option 2, this is option 3. So option 1 is this expression here. It's going to be x over sorry, x times x minus 1 over 3x and then 3x take 1. And then we've got option 2, which I'm going to put here, which is that one, 20 over 3x and then 3x take 1. And then the last one is a 2x take 5, 2x take 6, divided by 3x and then a 3x take 1. Now, you may have noticed that I've left the insides blank. I haven't put anything there. Remember, it's just going to be this, isn't it? It's going to be this one, or this one, or this one, right? Now, when you're dealing with probabilities, remember, we know that and means to multiply, or means you add them together, right? Because it's the probability of getting the same color. It can either happen this way, option 1, or that way, option 2, or the other way, option 3. And you add these together. So just bear in mind, or just means that we add these together. So all we're going to do is I'm just going to put a plus symbol here, like this. Plus here, and a plus here. Now, this is just another algebraic fraction problem, isn't it? Because what I've got here is I've got 3 fractions, and they all have the same denominator, to be fair. So what we can do is we're just going to put a big fraction bar, and we're just going to put these all over each other. And then that was just a matter of just expanding and simplifying. So I'll put this here, 3x, and then 3x take 1. And I'm going to put all of these here. It's going to be x minus 1, plus the 20, plus the 2x minus 5, and then 2x minus 6. And I just need to expand and simplify all of these here. So let me just make this a little bit shorter. Okay, so doing this now, this isn't too bad now, I don't think. So it's going to be equals here, and another equals here. Going to get another line. And then I'm just going to expand everything, aren't I? So it's going to be x squared, take away x, right? Plus 20, plus, and then I've got 2x times a 2x, that's going to be 4x squared. I've got a 2x times a minus 6, which is a minus 12x. Let me just double check that. 2, yeah, that's fine. And then minus 5 times 2 is going to be a minus 10x, like this. And then minus 5 times a minus 6 is going to be a positive 30. And on the denominator, we can expand that to give us 9x squared minus 3x, isn't it? So we've got this here. Now, we just need to tidy up a bit more. Now, getting all of the x squareds together, I've got an x squared plus a 4x squared. This is going to be a 5x squared. And let's have a look at the x terms. I've got a minus x here. I've got a minus 12x and I've got a minus 10x, right? Now, minus 12 minus 10 is going to be minus 22. So this is minus 22x right here. And then I'm taking away an x. That's going to give me minus 23x altogether. And then the constant terms, the numbers, I've got a plus 20 here and I've got a plus 30. That just makes a 50, isn't it? So I get plus 50 here. And then this is all divided by 9x squared minus 3x, like this. And this is our final answer. This is an expression for taking the same counter, right? Now let's look at the form that they wanted it in, right? So it says give your answer as a fraction in the form of that there. So we need a quadratic on the top and another quadratic on the bottom. And we've got this here, don't we? Got this here. Yeah, perfect. And that would mean you don't need to write this, but it's always just good to be super clear. You can just list your values of A, B, C, D, and E. A is equal to 5, B is equal to minus 23, C is equal to 50, D is equal to 9, put a square there so it's clear, and then E is equal to negative 3. And that's it, and that will give you the 5 marks. And that is the end of paper 3. Hi guys, Daniel here. So yeah, we made it to the end of paper 3, and that concludes the entirety of Edexcel GCSE Maths for 2023. And hopefully you didn't find this paper too challenging. And if there were any tricky parts, especially at the end, as you can see, hopefully this video has helped you understand it a bit better, and you're in a better position for the rest of your exams. And yeah, that's pretty much it for me. Thank you for all the support. Again, if you found the video helpful, it would be great for you to just drop a like, comment, subscribe. And yeah, wishing you the best of luck for paper 2 and paper 3 and the rest of your GCSEs. You guys are gonna do really, really well. Just make sure you're doing past papers. That's the key. But yeah, we'll leave it there. Have a good rest of your exam period, and I'll see you soon. Take care. Bye bye.